Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 5th. First up, we take a look at significant wave heights for the South Pacific Ocean. We see part of a gale here, only generating 20-foot seas, impacting New Zealand directly, and really having no source of swell relative to Hawaii, U.S. West Coast, or for that matter, barely even Fiji. Otherwise, cutoff low, southeast of Tahiti, creating 22-foot seas, aimed mainly at Central America and of not a lot of concern. And of more interest, and in not a good way, is fetch east of northern New Zealand, pushing south, generating barely 20-foot seas, and rather a fragmented pattern appearing to set up. Let's get into the details. So we'll start our tour by looking at jet stream level winds. These winds up about 30,000 feet help support the formations of storms, and when those storms do form, help direct their track. What we're looking for is troughs, that is, wind in the southern branch of the jet. There's typically two branches, one here to the north, one to the south, and we're looking for it to push to the north to do this sort of a thing here, creating a trough that sets up clockwise circulation at the ocean surface, and that is what is the hallmark of low pressure in the southern hemisphere. Anyway, we see a trough setting up here currently south of New Zealand. Decent winds pushing up into it, about 110 knot winds. We really want to see about 130 to 140, but nonetheless supportive of probably low pressure in this area. Put this into motion. That trough continues through about Monday, but notice winds get progressively weaker. And also notice here a big, what we call a ridge, that is the jet stream pushing to the south, and that does the exact opposite of supporting low pressure. It supports high pressure here north of the trough, and that's what we don't want to see, or north of the ridge. So basically this little area here is the only area of interest currently, or as by Tuesday, and that will be fading out as we see. And then we move into this where there's this ridge pattern going the whole way across the South Pacific Ocean by Thursday, and between the two branches of the jet, you end up with high pressure. High pressure lock is supposed to lock down the South Pacific by about midweek. And then let's see where that goes. It continues. Notice the ridge only builds into the weekend. That's Saturday the 11th, continuing, and just this ridge just digging down over the Ross Ice Shelf into Antarctica the whole way across the South Pacific Ocean, and that continues into the end of the 1 week run out to late Sunday night a week from now, and no signs of any troughs anywhere to be seen. This is not good. This does not support storm formation. So it looks like the run of southern hemi swell that is on the way. There is some two different swells currently on the way. They're already hitting Hawaii, bound for California, but after that, it looks like a shutdown in the wave production machine is likely, at least at jet stream level. Let's go take a look at the surface. Next up, we take a look at surface level pressure, surface level winds. It is winds at the ocean surface that generate seas, and those seas, as they move away from the fetch, or the winds that create them, turns into swell, and swell is, of course, what we surf. So currently, what we have is a broad area of low pressure here in the southeast of New Zealand, down at about 964 millibars, basically over top of Antarctic ice, running right around this rough area. We see fetch here, weak fetch, 30 knot winds pushing up to New Zealand, not doing a whole lot. We also see another area of almost 40 knot winds pushing due south again. So these winds here are obstructed relative to California and Hawaii by New Zealand. These winds are pushing into Antarctica, do nothing for us. This is what we call a cutoff low. It's north of the southern branch of the jet stream, south of the northern branch, caught between the two. Typically, there isn't a whole lot of fuel to support development here. Little area of 30 or 35 knot winds. And again, just nothing really going on. Roll this out. Continue. Notice also high pressure here. More winds pushing to the south. This area develops 30 knot winds. But just, we need more than that. The only fetch that's really of interest is all targeting Antarctica, other than a local low pushing into southern Chile supposedly on Tuesday. Little bit of fetch here, 30 knot winds, starts working its way east of southern New Zealand and pushing its way up the coast. That's on Tuesday night into Wednesday. Maybe a little hope for Hawaii from this, but on the other side of this low, it's going the exact opposite, wrong direction. Also notice high pressure, 1028, building over the Tasman Sea. Locking down that area as well. A nice little gale tries to organize south of Tasmania on near Friday, but again, a lot of this fetch is all pushing to the south, driven by high pressure. Here's the gradient, and they'll just follow the isobars, and that's where the wind's going. And so we're into the weekend again, still just nothing really going on. High pressure moves its way off of New Zealand. All this fetch here to the south, again to the south here. Here comes another system, 45 knot winds, again, all aimed to the south. Of no real interest. We're out 156 hours, and now we're into Sunday. We're out a week, and there's a little bit of a low trying to get going here, but high pressure, again, just totally locking down the southern hemi. Again, northern jet stream, branch of the jet stream here, southern branch down here, and just as expected, two big high pressure systems just in control. Little bit of a low down here. Antarctic ice is off about here, so some of this fetch is exposed to open water, but a lot of it not. Let's go take a look and see what effect all this has on the ocean surface in terms of sea production. So here we go, significant wave height chart for the South Pacific Ocean. We're going back a week ago, and I think we detailed this in the last report. We'll go through it real quick. First off, a gale pushed under southern Australia. This was Saturday a week ago, the 27th of June. Produced some decent seas, and just real quick, here's the rough swell windows. This was in relative to California, and relative to Hawaii, the window starts about here. Anyway, this system pushed out. Another one developed quickly behind it right there. 46-foot seas relative to Northern California, just barely on the Great Circle track. That's about the 220-degree track, 222-degree track, 221 into Southern California, and shadowed by Hawaii initially. But then it pulled out just barely east of New Zealand and created swell. So the swell from the first of these two systems has already hit Hawaii. The swell from the second one is starting to work its way into Hawaii. The first swell relative to the U.S. is just maybe starting to tease on the buoys a little bit, but it won't be till Tuesday till we really see much, and mainly Wednesday. Anyway, and then the second stronger storm swell from that should be right behind. So it's mainly a work week swell into the early part of the weekend for California. Anyway, we rolled through that through the rest of last week, through this coming weekend. Here's this little fetch here. Now, relative to Tahiti, this system created some swell. And here we go. Now we're current time, and just a little bit of seas left and not a whole lot else going on. And we just roll this out and you'll sort of get the picture of what's going on. If you don't see at least 28-foot seas in here, you probably aren't going to see a whole lot relative to the U.S. West Coast. Also notice the tropics very active. We'll get into that in a minute. But here we go. We're just rolling this out, and there's just nothing going on, and we're out 150 hours. Now, some more systems forecast to track under Australia a week out. Hard to believe that far out, but basically not a whole lot going on. Let's do a quick look of the Northern Hemisphere. And we're going right to the significant sea height chart for the North Pacific because, by and large, there's not a whole lot happening. Of note, though, there is a major westerly wind burst in effect right now over the equator in the far southwest Pacific. It is quite normal to have tropical activity form when westerly wind bursts are strong enough. That is an actual reversal of trades in the far west Pacific, and basically it sets up a counterclockwise eddy, and that is what forms tropical storms. So currently we have Typhoon Chan-Ham right here, forecast to build to 125 knots, working its way to the northwest. And Typhoon Nangka is supposed to follow, develop, and build to 110 knots, following a very similar path. And we'll just put these in motion here. Also notice off the southeast of Hawaii, as westerly winds build themselves, as this westerly wind burst expands towards south of Hawaii, it is all supposed to spin up a tropical system here as well. Anyway, anyway, put this into motion. We want to see these recurve to the northeast. That would be some sort of a sign of El Nino. We're not seeing that. And notice the tropical system here, we're 138 hours out, so a Saturday week out, goes north of Oahu. This other system, Nang Ka, was supposed to go directly following the system behind it, but now it looks like it's supposed to stall and build and maybe take a northerly route. Too early to know for sure. The model's teased on the one before it as well. But if it does this sort of a thing, it's entirely possible that some minor swell could radiate out the north way. Now, if it were to recurve northeast, that would be a massive sign, especially this early in July. It'd be a massive sign that something is biased in favor of El Nino, and that an El Nino pattern, not just down in this area and in the tropics, but up here in the jet stream level is taking effect. But again, this is 180 hours out. Completely unbelievable. Tropical systems, you do not really trust any model more than a day or two out, and we're 7.5 days beyond that. So we're in fantasy land right now. And to a certain extent, the same is true with this. But on the other note, both these systems have been on the models for a while now. So something to watch this week, and of course, we'll certainly be updating it a week from now, depending on how this all plays out. We'll keep our eyes on it. Let's go take a look, since we're talking about El Nino, and see where we are in its progression. First up, the Southern Oscillation Index, difference in pressure between Tahiti and Darwin, Australia. If the difference is negative, as it has been here since about the 19th of June, and extremely negative, down to minus 48.9, and continues on this bender, that's a really good sign. That's suggestive of El Nino. The 30-day, so the current average, or the daily numbers, are minus 30.7. The 30-day running average is down to minus 15.11. The 90-day running average is down to minus 10.6. We want to see this go down somewhere in about the minus 15 and stay there and hold. Now, we don't really expect that to happen. We are in the peak of the active phase of the MJO, and that's what's driving all this. The MJO interacting with El Nino a bit, amplifying it, creating these very deep numbers. We'll see what happens about a couple of weeks out from now, but right now things are looking very good. And to put the 30-day SOI average into historical perspective, back as far as January 2013, here's where we were. In the late May time frame, we went into the inactive phase of the MJO, lost all kinds of ground, and now we're back into the active phase and just about reaching this deepest point, and the deepest point in years, really, probably since the 2009-2010 El Nino. So this is a good place. This is exactly where we want to be. You can definitely see these spikes in the peaks up here in the positive range are the inactive phase of the MJO. The downward spikes are the active phase of the MJO. We want to see this whole thing continue to go downward. But if you sit here and draw a line just through this, just imaginary, you can see the trend is definitely downward, and that's exactly where we're going to be. It is El Nino relative to California and Hawaii that helps support the formation, or is part of a signal of El Nino, and El Nino helps support storm development in the Gulf of Alaska in the winter months, and that is a good thing relative to California and Hawaii. Up to a point, it helps support storm formation, which in turn creates swell, but too much El Nino can create lots of bad weather into California and Hawaii, lots of rain, and basically wash out whatever swell you get. But given the drought in California, if the net result in the end is a bunch of rain, that is not a bad deal. Relative to Australia, El Nino does pretty much the opposite thing. Locks high pressure down over Southeast Australia, creates drought, wildfires, and sort of where California has been for the past 4 years. So maybe it's time for the pattern to flip, and Australia will suffer for a while California will get some relief. So relative to monitoring not so much El Nino, but the active, inactive phase of the MJO, you look for changes in wind direction, and this is up at about 4,500 feet, the 850 millibar level, but it's a good proxy for what's going on down at the surface. And clearly, normally in this area you have trades, easterly anomalies. We are nowhere near that. We have massive westerly anomalies. That's winds coming from the west, just ripping out, and we're really interested in the equator region. Maybe we say 3 degrees either side of the equator, starting at about 130, and draw a box right here. If you've got westerly winds in here, that helps support formation of a Kelvin wave. And what's a Kelvin wave? Well, a Kelvin wave is warm water. Normally, there's lots of warm water here. When you get these westerly anomalies, the warm water in this area starts moving to the east, and then it falls to depth and tracks under the equator down about 200 meters, and then eventually gurgles up over the Galapagos Islands and creates a warm pool off of Ecuador and the Galapagos. And if that warm pool lasts long enough and builds large enough and gets warm enough, it is basically what El Nino is all about. That's what sets up the circulation change in the atmosphere. Anyway, currently, massive, strong westerly anomalies in control due to the interaction of the active phase of the MJO and an El Nino-based state. Plenty of activity here going. This should certainly help create yet another Kelvin wave, one of at least three that have occurred. This would be the third for this year, and this likely will be the strongest and the largest of any of those three. Next, we look off to the, here is the date line here. Hawaii is off to the side, so we go down, here we go, and look at Hawaii here. Strong westerly anomalies, making it the whole way. California is at about 122, so westerly anomalies the whole way across the Pacific to a point south of California on the equator. And as we talked earlier, these westerly anomalies could help to create a counterclockwise circulation. In fact, you can see it just starting right there, and that would be literally the early genesis of perhaps a tropical system that could have some impact to the Hawaiian waters. Another way to look at this, now we're going back, these are daily, this is again 850 millibar, but day by day starting June 29th, you see the westerly anomalies. Here's the equator right here, there's Australia, West Pacific, and if you just scroll through this real quick, you can just see this thing blooming by July 3rd, and again, we'll just go through that real quick. Moderate there in size, growing, I mean literally filling the whole way from the Philippines to the date line, and now almost south of California, and that's at the 3rd of July, and this thing is still going. Very impressive indeed. So we go a week from now out to the 13th of July, and what do we see? Still solid westerly anomalies in this area. This is looking very much like what the El Nino, the big 97 El Nino looked like. It sort of did this thing almost continuously. It kind of was stronger at some times, not as strong in others, but continuous westerly anomalies. And the reality is we've had westerly anomalies all year, not as strong as what's happening right now. They have gotten strong during the two major Kelvin waves, one that was formed in March and another that was in May. And now here's the third one going. Also notice this is also feeding tropical activity here. This is the second of those two tropical storms tropical systems we talked about. Anyway, and we roll looking to the east, and here we go. Yet more strong westerly anomalies 180 hours out, working the whole way to a point about south of California and holding. Very impressive indeed. And then here's this system that we talked about relative to why that's projected. Again, these are just projections, but pretty impressive. And here's another way to put it in perspective. This is time going 5th of June, working its way closer. And the area that we're in, this is the whole world, wrapping the whole way around the world, but it's the area between about 130 east and about 70 west that we're interested in. So back in June, we saw what was the inactive phase of the MJ. You can see it right there. The blues are easterly anomalies. Down at the surface, it didn't manifest. It just basically trades turned normal for about 8 days, and that was it. It's the oranges and yellows that are westerly anomalies. We see 20th of June, we started getting some solid westerly anomalies, but look at this. We're already through this just raging out-and-out westerly winds, not anomalies, out-and-out westerly winds. And the forecast has it going, here you go, sort of in the far West Pacific and then moving towards, oh, here we go, here's the scale, just to about 170 about 170 west, and this is from, so basically June 26th is the meat of it into July 12th. That is very solid indeed, right where you need it to be in the heart of the Kelvin wave generation area. A large Kelvin wave should result. And finally, one other way to look at this. Here's the 130. This is the these are from the TAO array buoys on the ocean surface, recording actual wind speeds or wind directions and speeds. You can see it here. A sort of a mix, not clearly as west as one would expect, but certainly strong westerly winds in a small area here, but is the anomalies, differences from normal, and that's what makes Kelvin waves. It doesn't have to be out and out westerly winds. Very strong anomalies in this whole area, working per this to about 140, just about there. So just a little bit east of a point south of Hawaii, all over the entire West Pacific. Very solid indeed. We'll come back to this chart in a second. So let's drill into the forecast a little bit. The blues, this is outgoing long wave radiation. This isn't winds, but this is suggestive of where the active phase of the MJO is. Blues suggest more precipitation than normal, less reflectivity off the ocean's surface, and roughly the active phase of the MJO. The inactive phase, per the statistic model, is building in the Indian Ocean, and over the next 15 days is to slowly work its way to the west and bleed into the West Pacific. The expectation, if this were to happen, is that westerly anomalies would dampen out. They would basically do what we're starting to see them do. They're west here. The westerly anomalies continue to work their way off to the east, and then eventually out of the Pacific, and easterly anomalies, or at least normal winds, would take over. But of more interest is the dynamic model, which suggests that the active phase of the MJO, just like the statistic model, is in the same place, but basically it's going to hold and slowly fade out. And what's even better per this is the inactive phase, rather than working its way into the West Pacific, is just going to die out in the Indian Ocean. Our thoughts are this is a more typical El Nino pattern versus this. The statistic model expects regular pulses of the active and inactive phase. The dynamic model is picking up on clues in the atmosphere, and we're hoping also accounting for an El Nino base state and saying maybe this is the outcome. We'll see. It's a week. This is 2 weeks out, so who knows? But notice that the two models are completely contradictory to one another. Then we have two other models here, the ECMF model and the Ensemble GFS model. Basically, so what these points are, so we got the Indian Ocean, the Maritime Continent, the West Pacific, and basically Africa area. And these are 8 quadrants looking the whole way around the planet, okay? And what they are doing here is mapping the position of the active phase, the core of the active phase of the MJO. And per this, the 4th of July, we are, or the 5th here, that's what we are today. This is the absolute peak of the MJO, the active phase. And also notice, if you're in the center, it's very weak. The further from the center you go, the stronger it is. Notice this is completely off the chart. Also notice this other model, completely off the chart. We are at the peak of this event per this model. But basically, rather than continuing on around and crashing around the planet, what it does per both these models is just stays here and weakens and slowly fades. And then it does work its way, it starts moving into other quadrants towards Africa and whatnot. By then, it's very weak. And this one actually shows a retrograde back into the almost the Maritime Continent. So who knows? I mean, we've got a bunch of different models all saying something different, but the consensus, at least of most of these, is not what the statistic model said, but maybe with some sort of a steady state fading active phase staying in the far West Pacific. And here we go with yet another model, a 40-day model, The blue, the greens here and the whites are the active phase of the MJO. This model has the active phase, or precipitation associated with the active phase. This is at the jet stream level, working its way out of the Pacific by the 15th of July. The inactive phase moving in, working its way across the entire Pacific through about the middle of August, and then another strong active phase developing and starting to show up in the West Pacific. So who knows? If we were to say that there is an area of concern, let's say that this inactive phase does develop as expected and works its way across the equatorial Pacific, what we'd be worried about is the development of easterly anomalies. Now, we don't think that's going to happen because we believe there's a good solid El Nino-based state in play, which means a bias towards westerly winds. And what we saw from the last inactive phase that came through in June is what happened is the westerly anomalies just sort of got tamped down, and they faded to neutral for about 8 days. And then basically we were back to westerly anomalies. So we'll see what happens here, but it is in this mid-ish to late July time frame that we'd be most concerned. If we really want some sort of a super El Nino or even a strong El Nino to develop, we want to see a continuation of westerly anomalies. That is the pump that pumps warm water to the East Pacific, and anything that dampens or inhibits westerly anomalies will impede the flow of warm water to the east, and that would be right in this time frame and right in this location if that were to happen. So, but after I think we get through the late July time frame, any chance of an inactive phase having any impact on our developing El Nino will be non-existent. So this is the last opportunity, maybe more just a cautionary note. We're not really sure anything will develop, but right when you think that everything's, golden, something can happen, and we have seen several potential El Ninos die in July. There's a lot more momentum behind this one, but just, again, a word of caution, a good point to be monitoring in the late July timeframe. Next up, sea surface temperature anomalies. Differences in normal for this time of year for these locations. Oranges are warmer than normal, and clearly we have a warm water pattern building here off the Galapagos and Ecuador. This the result of first a Kelvin wave that hit in the late May timeframe, early June. A second Kelvin wave that is sitting right under the ocean surface here, starting to gurgle up, feeding the warm pool, and now with westerly anomalies blowing over in here, yet a third Kelvin wave more than likely developing in this region, but it's got 3 months to go to get over to here. So currently, a nice warm pool here. Of course, plenty of warm water up here. We think this is all attributable to the, I'll call it the active phase of the Pacific Decadal Oscillation. Also, cooler water here off Africa, part of an El Nino signal. We're also looking for cooler water to develop here along Australia. Yes, it is cooler, but it's not markedly cooler yet. That would be another El Nino sign. But right now, a reasonable El Nino signature trying to get a foothold. We'll go back to June 5th just to sort of compare, see what's happened over the past 7 days or so. And you can see that, yes, it is building, but in that short of a time period, not a whole lot, but some building going on and continued development. And then relative to early June, now we can play this way too. You can see definite, significant expansion of warm water. So this early in June is when the first Kelvin wave just started hitting. And notice we were already in a very warm pattern anyway. That, the hangover from the year before when we almost had El Nino, that sort of like pre-staged everything, got warm water set up. So now as more warm water shows up, it's got a great base state. It's not like in having to come from negative temperature like in the 97 El Nino. But so looking pretty good at the moment. But we also want to compare this. Everything is compared to the 97 El Nino, the strongest El Nino ever. And so notice here's where we were in, this was July 1st here. And we'll just sort of go back and forth. The pictures are a little bit different, but you can sort of make it out. The 97 El Nino, warm water really started blooming come late June into early July. We are nowhere near that point as of right now. But That's not to say that we might not get there, or at least get into more respectable territory, because remember, there is a massive Kelvin wave under the ocean surface right here that is just on the verge of erupting now. And we can dive in a little deeper. We saw this chart before. Here is anomalies, surface temperatures, 2.5 degree anomalies here at 110 west, and growing 2 degree anomalies, 1.5 degree anomalies over the entirety of the Nino region. This is from 170 to about 120. That's the Nino 3.4 region. What we want to see, and notice this area here is building as well. This is a new pocket of 2 degree anomalies right here. But what we want to see is all this area in here start filling in with at least 2 degree, let's say, 1.75 to 2 degree anomalies. What we're really seeing, so this is the CDAS Nino 3.4 index. This is the average temperature over the whole area that we were talking about, the Nino 3.4 area used for monitoring El Nino. Current value, 1.466, so about 1.5 degrees. And that's almost exactly what it looks like when you eyeball it looking at the chart. Wherever that was here, you sort of go, okay, well, I'm trying to get the average temperature between here and maybe up to 5 degrees south and north and just put a box there. And sure, I have warm anomalies here, but I'm not that warm out here. And that's what we need, is this warm water to start building out here. When it does that, that's what starts supercharging the North Pacific jet stream. And so when you get into fall, storm activity just starts going nuts in the Gulf of Alaska and even over in the Dateline region. And storm develop, you just get string after string of storms going, and then lots of surf results, and then possibly precipitation as you work your way into January. So we got a ways to go, but we're still not horribly bad. 1.5 degree anomalies is certainly El Nino territory, and this like the first couple of days of July. So if we can stay here or better and get up into this region, if we got up to 2 degree anomalies, we're in very strong El Nino status. So we're actually in a great place for July. So just to zoom in, what we're really monitoring here is, notice these dark pockets here. We saw 5 of them about a week ago. Now we have 1, 2, 3, 4, 5, 6, and it's all turning into a blur. They're all sort of getting connected, and the temperatures here in these pockets are 4 to 5 degrees above normal. And notice these darker pockets are more than 5 degrees here. And what we think this is the early signs of another Kelvin wave starting to just tease the coast here and starting to gurgle up to the surface. So 5 degrees centigrade is better than 10 degrees Fahrenheit above normal. And what you want to see is this water then start working its way off here into the Nino 3.4 region. The more warm water you get here, the trades are blowing, they carry this off this way. We also have a virtual station here. Current data says the anomaly just for this little patch right here, confirming 4.6 degrees roughly, and that is cooking warm, to say the least. We had seen anomalies up to about 5.2, 5.1 maybe 2 weeks ago. It backed off a little bit. Now it's on the rise again. Just eyeballing the chart, that's exactly what we see as well. And yet one more view, we're looking at warm water here along the coast of Peru, and then all this warm water also advecting off of the Galapagos. This is as of June 25th. Here's where we are on July 5th. We'll just sort of play this back and forth. What we're seeing is expansion of, so the core is basically the same. We'll play that back and forth, little pockets of warm, but what we're also seeing is the expansion of warmer temperatures out on the peripheries as well, filling in back in these areas. And that's exactly what we'd want to expect, to see the expansion of this pocket, and then the trades take it off to the east. And finally, we're running a little bit long here, so we'll wrap this up pretty quick. Subsurface temperature anomalies, actual temperatures. This is the West Pacific, the East Pacific, buoys, the sensors on the buoy strings, but it's the anomalies. Here's the big Kelvin wave we were talking about. 4, 5, 6, almost looking like 7 degree anomalies. Now the last array here died out, which is not a good thing. So we're guessing at how far to the east this goes, and guessing on when it's going to westerly winds blow here, warm water falls to depth, travels as a pocket across here over about a 2.5 month period. impacts the Galapagos and Ecuador, gurgles up to the surface, and creates that warm pool that we've been seeing. So there's one view of it. Here's yet another view of it. We're not sure where this edge really is because there's no sensors here, but this line here is the coast of Ecuador. And so what we're doing is measuring what's going on at the surface to know when the actual eruption starts. But the point being here also, look at this. Warm water goes the whole way to 140 west, so that's, you know, halfway between California and Hawaii, if not more, and it will take probably at least 2 months for all that warm water to move into Ecuador, gurgle up. And what's also happening is we have westerly winds here. A new pocket's going to form here, and it's going to come right on in here behind here and just keep the warm water pump going. That's exactly what we want to see. So to wrap this thing up real quick, and finally, the forecast for the Nino 3.4 sea surface temperatures. Here's where we are right in now, July time frame. This says 1.25 degree anomalies, Nino 3.4. We saw actuals up in about the 1.5 degree range, so the model's, if anything, undercalling a little bit. If that's the case, notice it's projected by, the late November time frame to be 2.05 degrees above normal. Maybe we'll see 2.1 or 2.2 in actuality. It all depends. The big if is what's going to happen in July with the next coming inactive phase of the MJO, or if it materializes at all. But for right now, we have two swells, probably not huge in size, but decent in period, coming from under New Zealand, already impacting Hawaii, bound for the U.S. West Coast. Good for certainly well-rideable southwest swell at good exposed breaks in California. And so that will give us something to ride. After that, certainly seems like a slowdown is on the way. We see the tropics expected to get fairly active south of Hawaii and also off in the far west Pacific. We're looking for recurvature of any of those systems as another sign of pending El Nino. And of course, all the other data says El Nino is already in play. The question is how strong, how massive is it going to get, how warm is it going to get, what's the impact going to be come December, January, February of next year. Too early to know, but certainly we are in a very good place. And we honestly think the Southern Hemi shutdown is just a temporary situation. We expect it to wake back up. El Nino should be having an effect there, building high pressure over Australia, forcing storms under it, and creating yet more southwest swell. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching, and we'll talk to you soon. Go get some waves. Bye-bye.